learners, today we are going to study about this circle theorems, and I'm going to give you the hints if you have circle problems. Number one, if a line passes through the center of the circle, then it is the diameter. If you don't see any tangent on the circle, then look for the triangle in this circle. So, okay, usually when we see the diameter of our circle, usually we have a triangle there, and that triangle is a right triangle. So we'll place here the symbol of perpendicularity. It means that that angle is 90 degrees. And also, if you are going to use this one as our subtended angle, then that subtended angle is standing on a same circle. Therefore, this angle is 1/2 of the central angle. We know that the central angle here is a straight line, and a straight line measures 180 degrees, and 1/2 of that is 90 degrees. Okay. Here class, if we see the diameter of our circle and there is a tangent, then this diameter and the tangent, they are perpendicular to each other, and of course the measure of this angle is 90 degrees. One is, if there are two radii, then we have this one. We have the center of our circle at point O, and we have a radius coming out from point O. This is our first radius, and the second radius. When we have two radii coming out from the center of our circle, think of an isosceles triangle. Now, where is the triangle here? Sometimes you have to draw your isosceles triangle. So, I'm going to draw now a chord from the ends of the two radii here. And this one is a chord. So you will see here that we have an isosceles triangle. The radius here is equal to the radius on the other side. So this one, by a symbol, we'll put a mark here signifying that these two radii are equal. Okay, let's discuss about the isosceles triangle class. In an isosceles triangle, we have two equal sides. This one is the radius, that radius there, this one. So this one is equal to the other radius here. So I'm going to put the mark here. Okay. If we have two equal sides, then we have two equal angles. And these angles are called base angles. So where are the base angles here? The base angles are opposite of the two equal sides. So let's take the first one. This one, where's the opposite angle of this one? This one is the opposite angle. And the other radius, where's the opposite angle of this radius? This one is the opposite angle of the second radius here. These two are called base angles, and they are equal. So let's put a mark here for these two to become equal. What do we call this one, class? Single angle, or we can call that the central angle. So this one here is called the vertex angle. It is only one, while the base angles are two. So, and don't forget that in any triangle, the sum of the interior angles is always equal to 180 degrees. The third one is if we have a subtended angle and we have only one, we may have like this. The subtended angle here is 1/2 of the central angle here. So for example, we have 50 degrees here, then the central angle is 100 degrees. Usually if we have only one subtended angle, but if we have two subtended angles or three subtended angles, that subtended angles standing on the same arc are equal or congruent. Now in this figure class, the center of the circle is at point O. So we don't have lines passing through the center of our circle. No. We can have this one is equal to this one. These two are congruent. These two angles here are also congruent. But when we have more lines drawn here, it will be more complicated. Then we have to resort to something like tracing the angles. So let me show you how to trace the angles here. For example, this one, we start from here and say this one is 32 degrees. So this one is 32. So we don't know here where the 32 degrees angle is. Maybe it can be here, or it can be there. So we will use the tracing of our fingers to locate where the 32 degrees is. So we start from here. I'm using the left finger and my right finger here. So my right finger will go down and trace the side of my angle here until I reach this point here. Then my left finger will trace this line or this side of the angle here, and I stop here. Now don't return back to your angle. Don't return like this or this. Trace another line. So this one, my right finger will trace this one here. It will stop here. My second finger will trace this line here. Therefore, this one is the 32 degrees. This 32 degrees and this one, they are both standing on the same arc, and that arc is this one here. What about this one? Suppose this one is 56 degrees, whereas the other 56 degrees. Then we resort to tracing. So here, I'm going there, and my left finger will trace the other line, on the other side of the angle, here. So this green arc is the common standing point. Then my right finger will trace this side here until I reach this point here, and this one will trace it here. Therefore, this one is also 56 degrees. So this and this are equal. This and this are equal. Now, if you don't have any lines, only these lines, then you can assume that this one and this one are equal, this one and this one are equal, both on the same side. But sometimes it becomes complicated. For example, it becomes, what is this one, class? It's a cyclic quadrilateral. Usually, when we have subtended angles, they are combined with the cyclic quadrilateral. So when we have cyclic quadrilateral here, it becomes confusing. Is if there is a triangle, then now our triangle here, class, the sides don't pass through the center. If you have a triangle like this, then look for the tangent. If you have a tangent line here, then look for the tangent here, and then this side here, from the tangent, from this side of the triangle to the tangent, not to the circle, to the tangent, is equal to its alternate segment, which is this one. So this one and this one, they are congruent or equal. The other one here, from the tangent to the side of our triangle here, is congruent or equal to that one. Look here, this cannot be there because this one is touching this side, that angle is touching also this side. The angle must not touch the side to become alternate. So this one touching, no. This one, yes, and then there. This one, no. Okay. Of course, this angle plus this angle plus this angle, straight line, equals 180 degrees. Number 5. So for number 5, if there are parallel lines, then what? The symbol for parallel lines is an arrow. We have an arrow here and an arrow here. It means that these two lines are parallel. When we have parallel lines, then we have the transversal angles. And usually we use the alternate angles or alternate interior angles or Z angles. It means that these two are the non-transversal lines, and the line that is passing through these two non-transversal lines is our transversal. Now, our line segment is only up to that point and up to this point. Now, you can prolong that one so that you will see that this line is a transversal. If you are confused when we have only a line segment, you can prolong it. Now, we know that this angle here, the alternate angle of this one is on the other side here, not here. So this angle here and this angle here is our alternate interior. Why is it called Z angles? Because we can draw like a Z here. There is that one, and we have a Z angles. So sometimes they are called Z angles. What about this angle here? This angle here and this angle here, they are alternate interior angles of our transversal, and they are also congruent or equal. So let's have some examples here, class. So here, look at the center of our circle as a point O, and there is a line or a chord that is passing through our center. Therefore, this is the diameter. Okay, here, this one is 33, which is the subtended angle, and we know that the X here is the central angle. The shortcut solution is, we know that the central angle is 2 times the measure of the subtended angle. So we just multiply this 33 by 2, then our X is 66 degrees. Now let's have another solution. Can you see this O going here? This one is the radius here, and the other radius is this side. So we have another radius. Therefore, in this triangle, this is an isosceles triangle. So because we have 2 equal sides, we have the base angles, which are also equal. If this one is 53, then where is the other 33 degrees? Where is the other base angle? That one is here. So this one is also 33 degrees. how do you find the vertex? Because this one is the vertex. So the vertex is, we add 33 plus 33 equals 66 and subtract it from 180 degrees. So that this one is 114 degrees. Now to get the x here, we know that this one is a straight line. And if we have a straight line, the measure of the angles there is equal to 180 degrees. So we just subtract 114 degrees from 180 degrees, and that will give us this 66 degrees. Okay, now let's set the second example here. Oh, we have a subtended angle and we have the central angle. We know that the subtended angle is 1/2 only of this central angle. But the problem here, class, is we don't have the central angle and we don't have the subtended angle. Now, this one is given the 40 degrees. And these two lines here, these two line segments here are the radius. This one's the radius here. And the other one is the radius here. We have two radii here. Now when we have two radii, it forms an isosceles triangle. So we have two equal sides, and the 40 being the opposite of one equal sides here is the base angle. So where's the other base angle? The base angle here, the other side is this one, which is also 40 degrees. This is a triangle, and in any triangle, the sum of the interior angles is always equal to 180 degrees. So if you are going to add the 40 and the 40 here, that is 80 degrees. We subtract it from 180, that central angle there will be 100 degrees. Now we can use our theorem of the subtended angle and the central angle. This one is 100 and the subtended angle is only 1/2 of the central angle, giving us 50 degrees for our subtended angle. We have this example here. We have the diameter of our circle because it passes through the center here at point O. This one is our diameter. Okay. When we have a triangle standing on the diameter of our circle, we have a right triangle here. So we have a right triangle, and where's that? That right triangle is here, 90 degrees. Now, this one is given 42 degrees. We'll have to find A, B, and C. So we can easily find A because A and the 42 degrees there, they are complementary angles. Means the sum is 90 degrees. This one and this one is 90 degrees. Therefore, if we add a 90, then we have 180 degrees. What is the measure of angle A here? So we just subtract from 90, we have 90 degrees minus that 42 degrees. So we have 8, and 8 minus 4 is 48 degrees. So angle A is simply 48 degrees. That is the measure of angle A. So check. Now, what is the measure of angle C? Angle C is easier to find than angle B because we have here and here radius of our circle, here and there. Now, this 42 degrees is the base angle, and the other base angle is the C. So without complications, we know that angle C is also 42 degrees. Now, how do we find B? We must add 42 and 42 and then subtract it from 180 degrees. So if we are going to add 242, it will give us 84 degrees. Then we subtract it from one is, so we have 96 degrees. So angle B is 96 degrees. Okay, let's have the last one, which is a little bit complicated. And we are going to apply our knowledge of some theorems about circle. We can see here, this one is the center of our circle, this is point O. And we have the radii here, this one and this one, they are equal because they are the radius of our circle. Now, to use this radii here, we need to put a line here so that it becomes an isosceles triangle. Now, in isosceles triangle, we know that this angle here and this angle here are equal. Then, the central angle 100 is given. The subtended angle here is unknown. You can just put here or compute easily this angle here, because this angle here is 1/2 of the central angle by theorem. So this one is 50 degrees, half of 100 degrees. In this triangle class, let us find the base angle, these two base angles here. So we subtract 100 degrees from 180 degrees, so that gives us 80 degrees. And then we divide it by 2, so this one is 40 degrees here, and the other one is also 40 degrees. We are looking for this angle here, a small angle here. This is also equal to the other angle there. That is x. X is not 40 degrees. X is not the whole thing there, but x is the smallest here. That is x, that one. Now, let us have this one. What do we mean by the symbol? The symbol means this chord here and the other chord there, they are equal. Now, if we are going to draw a line here, we will have again an isosceles triangle. Now we locate the base angles of this isosceles big triangle, in which the vertex angle is 50 degrees. So where is the base angles of this big isosceles triangle? That one is the whole. This one. From here, not from here, from here up to there is the base angle. The base angle on the other side is from here going here. So let us compute this base angle of this large isosceles triangle. So this one is 50 degrees. Subtract it from 180 degrees. Then we have 130 degrees. Then we divide it into 2. 65 here and 65 there. So here we have 65 degrees. That is the base angle of the larger isosceles triangle. But this one is 40 degrees, the base angle of the smaller isosceles triangle. Therefore, to find x, we just subtract 40 degrees from 65 degrees. So that gives us 65 minus 40 degrees. So the answer for x is 25